All right, guys, now we're going to look at the complex number system, complex numbers. The number I is the main deal here with complex numbers. I, when you ever see the number I, it is a square root of -1. That's what it equals, a square root of -1. I is not a variable. I is a square root of -1. And if that's the case, then obviously I squared must equal -1. That's what I really need you to know right there. I squared is -1. I squared is -1. All right, so they're going to say express each number in terms of I. What I enables us to have the opportunity to do is take the square root of a negative number. So when I see the square root of -7, I can break it down like this. I'm not going to do this every time, but just this time. I can break -7 down like -1 times 7. And we already know the square root of -1 is just I. And I don't know the square root of 7, so I'm going to leave it in there. So I'm just going to take the I out and write I on 7. That's simple. So part B, square root of -16, take the I out first. That makes it positive inside. Square root of 16 is 4I. C, there's a negative sign outside. That's got to stay. If I take the I out, it makes the square root positive. And I can't break down 13, so I'll just stop at 13. D, there's a negative outside already. To make my square root become positive, I'm going to take an I out, and it becomes positive 64 inside. But I know the square root of 64 is 8, so I'm going to write it just like this, -8I. I always like to write the I last if it's a integer. And if it comes with a radical, I usually put it in front of the radical, so you can tell that it's not inside the radical. Part E, same deal. Take out the I, make it square root of 48. And you're going to break down 48. 48 is really 16 times 3. So I'm going to take out the square root of 16. The square root of 16 is 4, but the 4I, I don't know the square root of 3. It stays in, and there they are. Complex numbers. Complex numbers look like this. They come in the form A plus BI. A and B are real numbers. The A part is called the real part because it doesn't have the I, and the BI is called the imaginary part, or B is said to be the imaginary part of the complex number. So complex number, A plus BI, A is the real part, B is the imaginary part. And this is what the whole number system looks like. To be honest with you, every single number falls into the heading of complex numbers, because complex numbers, A plus BI, could be stuff like 5 plus 2I, square root of 7I, 2/3, but it could also be like 7. 7 is like 7 plus 0I. Square root of 2 plus 0I. All those are complex numbers. Complex numbers get broken down two ways, either imaginary or real. That should make sense to you. If it's not real, it's imaginary. Imaginary will always have one part that has an I with it. It could be complex. It could just be flat out imaginary number just with an I. And you can break down imaginary with imaginary complex numbers, or pure imaginary, which means they have nothing except for just the term with the I. Real numbers, we've talked about these already this year. Real numbers are when your B is 0, there is no imaginary part, and you can break down reals as in irrational and rational, and that keeps going down to integers and whole numbers and natural numbers. It just keeps on going. But every number, what I want you to get from this slide is every single number is a complex number. Okay, we're going to add the subtract them. That's not very difficult to do when you add. All we're going to do is we're going to add the real parts. 8 plus 3 is 11. We're going to add the imaginary parts. 6 plus 2 is 8. And that's all you do. Just add the real parts, add the imaginary parts. When you subtract, you may want to take a step to make sure you get this. That minus sign in front of the parentheses changes the sign on the 6 and the 3i. And now it's just an addition problem again. So combine your 4 and -6, that's -2. Combine your 5i and 3i, that's 8i, and there you have it. Addition and subtraction. You probably guess what's coming next, multiply and then simplify. So on the first one right here, I'm just going to do flat out FOIL method. So I got 1 times 1 is 1, that's first. Outer, I have 3i. Inner, I have 2i. Last, I have 6i squared. Now, two things here. First of all, I see the 3i and 2i. That's going to be 5i. The second thing is I have an I squared. You are never, ever allowed to leave an I squared in an answer because you know I squared is -1. So it's really a -1 times 6, which is -6. And if you add the -6 to the 1, you get -5. Hope that makes some sense. If that doesn't make sense, you might want to rerun that and watch that part one more time. But don't leave an I squared. That's the main deal. All right, this one, the next one. 3 minus 7i squared. Don't forget the shortcut we had. You square the first number. You multiply them together, which would be -21i, then you double it, -42i. Then you square the second one, which would be 49i squared. All right, now, same deal. I cannot leave an I squared. I squared is really negative 1, so it really says negative 1 times positive 49, which is really negative 49. So 9 minus the 49 is negative 40 plus 42i. And that's all you got to do on that one. On the last one, multiply, but notice they're both negative square roots. You can't multiply negative square roots, so take an I out. That gives me I on 16. Take an I out of the second one, I on 25. Now, hopefully you know the square root of 16 is 4, so that's really 4i. And hopefully you also know that the square root of 25 is 5i. When you multiply those, you get 20i squared. But don't forget, don't leave an I squared. An I squared is really negative 1. 20 times negative 1, negative 20. A couple more things here. Okay, they're going to give you some i's with exponents. What I want you to do is do this. I want you to break them down using I squared. So it looks like this. I'm going to put an I squared here and think how many times is 2 going to 37? Well, 2 goes into 37 18 times. So that right there, that expression represents 36 i's because 2 times 18 is 36. So I'm going to put one more I out here. So what I just did is I broke down 37 i's like that. And don't forget, I squared is really negative 1. So that really says negative 1 to the 18th power. Anytime you raise a negative number to an even power, it becomes positive. So it becomes positive 1 times I, which is just I. All right, look at the second one. I to the 75th power. I'm going to use I squared again. And think about what is half of 75. Half of 75 is 37. But that's only 74 i's, so I'm going to put one more I out here like I did last time. That represents 75 i's. I squared is negative 1. Now this time, if you do negative 1 to an odd power, it stays negative 1. So that's really negative 1 times I, which gives you negative I. All right, a couple more. So I'm trying to even one here. These are actually a little bit easier. Probably should have done these first. I squared. I'm breaking down with I squared. I'm going to figure out what half of 58 is, which is 29. Don't forget, I squared is really negative 1. So it's really negative 1 to an odd power. So it's going to stay negative. So I'm going to put negative 1. That's all you do. Negative 1 to the 29th power is negative 1. One more of these, same deal. Use I squared because that's the term we know is negative 1. Half of 80 is 40. So that right there represents 80 i's. I squared is really negative 1. Negative 1 to an even power makes it positive, and it makes it positive 1. So when you have I to some power, it's always going to be either plus or minus I or plus or minus 1 every time. All right, conjugates. Conjugate of complex numbers. We're going to use these a lot. Make sure you know the word too, conjugate. The conjugate of a plus bi is a minus bi. Conjugate just means you're changing the sign on the imaginary part. Okay? A plus bi, a minus bi. If I saw 4 plus 2i, the conjugate would be 4 minus 2i. Okay, just change the sign on the imaginary part. So, the good news about conjugates is they're easy to multiply. If you multiply conjugates, watch what happens if I do FOIL here. If I do FOIL, if I do first, outer, inner, last, look what happens to my middle terms. I got a negative 6 out and a positive 6 out, they're gone. That's going to happen every time. And not only that, I have an I squared right there, which is really negative 1. So I really have negative 9 times negative 1, which is really plus 9. 4 plus 9 is 13. So here's the deal. We're going to talk about this in class tomorrow. When you multiply conjugates, you don't have to do FOIL. You can just do FL. Much quicker, easier, etc. Okay, second one here. If I multiply these two, these are conjugates because they'll change the sign on the imaginary part. So if I multiply those two, I do get negative 16i squared. Don't forget I squared is negative 1. Negative 1 times negative 16 would be positive 16, and that's all you got. Okay, last thing is just division. This is the last slide, last step. So when it says divide, I'm actually going to write it like a fraction, like this. And I think this is how your book's going to present it to you. Now, what is illegal about this? What you got to be careful of, you're not ever allowed to leave an I in your denominator, because you got to think back to the very first slide. I is really the square root of negative 1, and you know you're not allowed to leave a square root in your denominator, so you're not allowed to leave an I in your denominator. So what we're going to do to get rid of it is what we did on the last slide. We're going to multiply by the conjugate of the denominator, which is 3 minus I. It's legal because I'm multiplying the numerator and denominator by 3 minus I, and I was really multiplying by 1, so that's just fine. On the bottom, watch what I do here on my denominators. I'm just, because they're conjugates, I'm going So I'm going to first, which is 3 times 3, that's 9. Last is I times negative I, which is negative I squared. Now, I'm going to go ahead and finish the denominator. I squared, remember, is really negative 1. So I'm really doing 9 minus negative 1, which is 9 plus 1, 10. All right, there's the denominator. The i's gone. That's the great thing about conjugates. All the i's always disappear. My numerator, I have no choice here except to multiply this times this, which means I'm doing FOIL in my numerator. 7 times 3 is 21. That's first. Outer, negative 7i. Inner, negative 12i. Last, plus 4i squared. All right, so I have these i's in the middle, which is, if I combine those, I get negative 19i. Now the I squared here, remember, is negative 1, so it's going to make that 4 become negative 4. So I have a 21 here, minus 4, which is 17, minus 19i over 10. Now, one thing to look for, be careful, look at all three numbers, see if you can reduce them in any way. Take a number out. This time we can't. Nothing goes into 17, 19, and 10, so I'm completely done. All right, hope it wasn't too bad. A lot of skills today, but you should have done most of this before. And I'll see you when you come in tomorrow. See you then.